Hi everyone, welcome to this presentation about the eye. And what I want to do is cover focusing on different things, such as things that are really close to you, which is called near point, and things that are very, very far away, which is called far point, and the way we define the range between the near point and the far point. And then in the other parts, which I'll save separately, I'm going to cover vision defects and how we correct them. By the way, I'm making this in an iPad app called Explain Everything. If you like this, if you like me doing this sort of thing, just let me know. I'm more than happy to do it more often. Okay, let's start off. I'll draw a diagram of the eye. So we've got the lens of the eye, we've got the eyeball, we've got the optic nerve, and at the top and the bottom of the eye, we've got some muscles, I'm just going to draw in like this, which are called ciliary muscles. Here and here. And what the ciliary muscles do, essentially, is they crunch the eye down. They change the shape of the lens of the eye, because obviously the lens in the eye is not a fixed lens, otherwise you would have to hold things, or you'd have to look at things a certain distance away from you all the time. Both the shape and the thickness of the lens of the eye is changed with the ciliary muscles. When you're looking at something that's very, very far away, your eye is relaxed, those muscles are totally relaxed, then the lens is at its thinnest. And when you want to look at something that's really close to you, in other words, you need to bend the light a lot to focus it on the retina, that's when the ciliary muscles do the most work. And that's why you find that when you're looking at something that's very, very close to you, for a long time especially, your eyes can get very sore. It's because of those muscles, those ciliary muscles. Over time, not only does the lens itself get a little bit less flexible, but also those muscles, just like other muscles in your body as you get older, those muscles get a little bit worn out. And so that's why older people especially find it a little bit harder to focus on things that are close to them, close to their face, because of those ciliary muscles essentially just getting a bit older, and the lens of the eye itself getting less and less flexible, less and less able to be kind of crunched down to the thickness it needs to focus on something close by. You'll often see older people, when they're reading or looking at something, they'll hold it way away from their face. They'll hold it right out. They'll hold a newspaper or a book away from them if they're not wearing glasses. Okay. All right, so let me just get rid of some of these things. So let's have a look now at what happens when you focus on something far away, something in the very distant, long, long way away, right on the horizon or further, like a star, for example. Now, focusing on something that's really, really far away, the light rays are basically parallel. They come into the eye like this, and then what the lens of the eye does is it converges these light rays and focuses them, and in the case of a star, for example, it's focusing them to a single point, right? A single point right here. There's a name for this, and it's called the far point. It's when you're focusing on something that is as far away as possible. Okay, so let's look at something else that we use to define the ability of the eye to focus on different things, and that is the opposite point. It's called the near point. It's when you focus on something that is very, very close to you. For example, I'm just going to put a point here. When you're focusing on something that's very, very close to you, what happens is, and I'll draw these light rays up from here. Here's light coming from this object that's very close, is the eye has to do a lot of work. The eye has to be, this lens needs to be crunched down and made as thick as possible, because what you need to do is you need to converge these light rays so that they come in and focus on the retina. So we're going to bend these light rays and focus them like so. Again, focusing them to a single point. And this, as I said, is called near point. It's the closest point that you can focus on. Now, just do a little bit of an experiment. I'd like you to hold your finger in a distance away from you and move it towards your eyes slowly until it goes out of focus. So what I'm basically trying to get you to do is to discover what your near point is. If you can, see if you can measure that. See if you can take a rough measurement and work out what it roughly is. Here's something interesting about the near point. I'm guessing that you'll probably get somewhere in the region of about, I'm just going to make a guess, around 10 centimetres. When you're around 10 years old, your near point is about 7 centimetres. Now here's something that you might find a little bit shocking is what your near point is right now. That's the best your eyes are going to be. You're not going to improve them. You can certainly exercise your eyes. You can build muscles just like you build normal muscles, but your near point, essentially, that's the best it's going to be. It's only going to get worse from here. To give you an example, my near point is probably around 20 centimetres. I know, it's a little bit disturbing. And it only gets worse. It only gets worse with time. They say that 60-year-olds have a near point of about 1 metre. So that point, the closest point in which you can actually focus something is just getting further and further away, just because of what's happening with the lens and also because of what's happening with the ciliary muscles. Now, a definition that we use, let me just take some of these things away. So, a definition that we use is accommodation. An accommodation or accommodation range is essentially the far point, the distance between the far point and the near point. And that is said to be the accommodation range of the lens. Now, in the next part, I'm going to talk about power, lens power, and how lenses in combination can add and subtract power, and that's going to lead into vision defects and how we can correct them.